morning all. So today we will be starting AR. Today we will be specifically looking at how to set up AR. Yeah, developing for AR requires a bit more setup than a typical Unity project because you are working with two separate machines, your computer and your AR device. So far we just looked at normal game development and then VR. Entire game development requires just one machine, your computer and Unity software. And similarly VR, you can simulate in your machine, or once you entirely do it, you just need to transport it to VR headset. There also you sort of require two devices, but AR is slightly more different. Here you need to keep the devices connected, and also some more settings you need to do in AR. So you need your computer as well as your device where the AR project actually runs, because it uses your mobile camera or iPad camera or whatever it is. So you need both these. The coding is done in the computer and the execution is done in the mobile device. Okay. You need to zero on to your target mobile operating system. You have to decide either it is iOS or Android, and because the steps are different for both. Okay, so you have to choose one of them. In this course, we will be discussing iOS. In case you want to do for Android, you can check these steps on your own. They are slightly similar to iOS thing, but setting up is mentioned in detail here, step by step. Okay. So what all are the things that you need for this? You need Xcode. I am only discussing iOS now. You need Xcode for your laptop, and I hope you all know what Xcode is. Xcode is the IDE, like Visual Studio Code. It is Apple's specialized IDE. And Unity. In Unity, there is a specific version. I forgot typing it. Let me just mention it. So this specific version you have to install. This is only for this for these lectures. After that, you can install any other version. Because we are following Unity's tutorial, we are installing the version which they are suggesting. Okay, so this specific version you need to install. And then once you install Unity, you also need to install some iOS module. Okay, because it's like a plugin. Everything doesn't come pre-installed with Unity. Whenever you need a specific package, you install that package. So here, iOS package you need to install. We will go through the steps. Okay, so this you can install either while installing Unity version, or suppose you have already installed this Unity version, you can add this module later also. So suppose I have these installs. Now suppose I want to install this editor. That editor is not listed here. You have to go to archive, and you can look for it on the website. But I'm just showing you how it looks. Suppose I want to install this. Now while installing, it will ask you what modules you want to install. Okay, you need not install Visual Studio because you already have it. Okay, but iOS build support you have to install if you are building for iOS, or if you are building for Android, you have to install Android build support. Okay, so this you can see while installing Unity version itself. But suppose if I already have the Unity version, but then I want to add this module later, then what you need to do, these are the installed versions. Then all you need to do is click on the settings icon and say add modules. And here you will see what modules are already installed. I have already installed iOS build support, so it is not showing the checkbox, but for you it will show the checkbox. You need to check that. Okay, so these are the two ways in which you can install. So install it along with the version or install it later. Both ways you can try. Okay, so this specific version you have to install. All right, so assuming you have the version, okay, the version and the iOS module, you can test a project. So there is a file which Unity community has provided. So I have uploaded that file in OneDrive, and I downloaded it to my machine. So all you need to do is download it and extract the folder in it, and create a project with this from this folder, right? Extract it locally and then add the folder as a Unity project in Unity Hub. So how to do that? In projects, click add and then select this particular folder. Okay, oh, this one, yeah. It will say right now I don't want to install that version. I will install it later, but I just to show you, I will use whatever version I have already. So again, it will show the change version button and I have to click it immediately. Oh, again it went to install. I need to. Yeah. So I immediately you have to click that button in case you want to use with a different version. So ignore any warnings. So I am ignoring the warnings, but I will install the other version by the next class. You also install the other version. Okay. So in this starter project, open window, package manager. So here you will see two options, packages in the project and packages in entire Unity registry. So suppose if you click packages in entire Unity registry, all the different possible packages you will see, but we want to focus right now only on the packages in the project. Okay, so these are some relevant packages. AI navigation. So AI navigation is not relevant right now. Later you can do some projects using that. So AI navigation, I don't know if you have heard of something called nav mesh. So it's used in many games, like suppose if you have a game where any game, I think I mentioned it earlier also, say you want the player to walk only along a few paths, you don't want the player to go to any different place, or say you don't want the player to walk through the walls, right? So how do you restrict it? Everything is just pixels. So to do that, there is something called nav mesh. So using that, we can suggest or we can specify what is walkable path and what is a non-walkable path. And using that, we also can sort of generate the map or the shortest path from one point to another point. Okay, so this is used in a lot of games. Okay, this is useful later in AI AR also. Okay, so this is one package, and then ARKit, Apple ARKit face tracking XR plugin and Apple ARKit XR plugin, AR Foundation. I'll explain those in a while. And then finally, XR plugin management. These are the most relevant and useful packages. So what are those? So AR Foundation. So this AR Foundation which you are seeing, this is developed by Unity itself to act as an interface for different platforms. Like I don't know if you remember one of the very first couple of lectures, we discussed different kinds of SDKs, different platforms, different tools that are available for AR VR. So if you want to develop AR applications for Google, you need to use AR code. Suppose if you're directly coding on Google Android, you have something called AR Studio. You can code there also. Unity is like one environment, and it is like multi-platform environment. You can code on Unity and then export to Apple or iOS or Android or Windows or different things. Whereas if you want to code specifically for Android AR applications, then you need to use AR Studio. Similarly, if you want to code specifically for iOS directly using Apple platform, you need to use ARKit. Okay, but in case you don't want to worry which platform you want to code for right now, you want to be platform independent, you can code on Unity and then export it either to iOS or Android. Okay, so the API or the interface between Unity and these two, ARKit and AR Core, that is AR Foundation. AR Foundation actually is an interface between Unity and any platform, either ARKit or AR Core. Okay, and all these plugins are managed using XR plugin management package. So basically, it will provide you the interface, which plugins to select, which plugins not to select. We will see that. So you may have all the plugins installed, but you don't want to enable all of them. So you want to enable few, you don't want to enable some. So there XR plugin management comes into picture. So it looks somewhat like this. So AR Core is specific for Android, ARKit is specific for iOS. These are SDKs, software development kits. You can code directly in them in case you want to develop for those specific platforms, or you can code in Unity if you are not sure of which platform right now. If you want to code independent of platform, or in future you want to export it to any platform, right? So it's better to code in Unity so that you can export to both the platforms. But if you code on any specific platform like AR Core, you can't export it to ARKit and vice versa. You have to again code on those separately. Okay, so AR Foundation is developed by Unity itself. It is an API, or it is an interface between AR Core and Unity and ARKit and Unity. Okay, and all these are plugins that are packages that you need to install or add to Unity. Like what did we do? We added iOS module, right? Or we added Android module. So these we need to add. So those are like plugins. So these plugins need to be installed and managed by something. So that management thing is XR plugin management. Okay, so this is the overall overview of the plugins. All right, so let's go back to the project. Yeah, so in this you see you have only two things right now, main camera and directional light. But what we will do, we will add a template, AR template. Okay, so let's select a new scene, and out of that select AR scene template. So you see, usually how do we add scenes? Earlier, how did we add scenes? We used to install a package, and in that package, in this assets folder, there used to be a scenes folder, and within those scenes folder, there used to be some pre-built scenes. We used to double click on that and our scene used to load. Okay, now we are not adding the scene from here, but we are creating the scene directly from file, new scene, and then some different scene templates are given. you can create some basic template or standard or empty or basic, different kinds of things are there. But what we are interested in right now is an AR scene template. Okay, so create an AR scene template. All right, so now you see there are some things that have changed. Earlier we just had main camera and directional light. Now we have directional light, AR session origin, AR session, and a cube. Okay, so visible things are the light and the cube. Okay, and within this AR session origin we also have AR camera. Okay, so this camera is different from, so AR camera is different from the usual camera. Why? Because the usual camera idea is that whatever you see through that camera is what you will see on your screen when you play. It can be a game or whatever, it can be VR headset or whatever. Whatever your camera sees, that's what you will see on your screen. Okay, but AR camera is slightly different because AR means what? I use my mobile camera. It can be iPad or phone. Whatever my mobile camera is seeing and whatever this AR camera is seeing, both need to be merged. Right? Whatever AR camera is seeing, that needs to be overlaid on my mobile camera view. So it should seem as if you take any example of say Snapchat filters or Pokemon Go or whatever it is. Those Snapchat filters are in some sense virtual content. Okay, but when it is overlaid on our face is real content. So my mobile camera is seeing something, my AR camera is seeing something. So both these things need to be merged. So AR camera's content needs to be merged on the device camera content. Okay, so this camera is different, AR camera is different. And in AR project, you should have only AR camera, no other camera. In case you have multiple cameras, remove all of them. But in earlier projects, we used to have multiple cameras. If you remember the VR project, we had a normal camera which is aligned with our headset. Then we had a camera in the mirror, right? And then we can have multiple cameras. We can switch to them or we can use them for different purposes. But here, you should have only AR camera, remove all of the cameras. And this AR camera represents the position of your mobile camera as well. So basically this AR session origin, this is similar to XR rig in VR project. What is XR rig? The entire setup, your head mounted display, your controllers, all these things and the camera, all these things are grouped together and treated as one unit. That is XR rig. Similarly here, AR session origin, here there is only one child, this AR camera, but this AR camera represents our mobile camera. So as our mobile moves, this AR camera moves. Okay, so wherever your mobile goes, whatever its orientation is, direction is, so your AR camera also changes in that orientation and direction. And why is it called AR session origin? It's called AR session origin because it needs to sort of map the world around it with some coordinates, and that mapping happens relevant to some origin. So the camera's position itself is the origin. So the moment the session starts, so session means okay, now I clicked on the now I opened an AR project, so now some session starts. Session means okay, so first let me play this, let me run this, and then let's see what happens. Okay, in this case there is a cube which is rotating, okay, and the entire background is black. All right, so what it means is there is no specific environment in which this cube is rotating. The background environment will be replaced with your camera content, with your mobile camera, whatever your mobile camera is seeing. Suppose if I am looking at this room with my mobile camera, so this room will be my background on which this cube will be overlaid, and this cube will be rotating in thin air. Okay, so that's what this black background means. All right, so let me see if I can show you that video. So it looks like this. Okay, so this will be visible to you only when you export your project onto your device. Okay, but right now this project is only in Unity, so you can't see this environment. You will only see a black background. All right, so that's what we are looking at. So this cube comes with a code, right? Rotation code, script. So it's a simple script. You have a public float rotate speed variable, and then the position where it needs to rotate. Okay, and that's all. So transform.rotate position into time.delta time into rotate speed. Now since rotate speed and position, not position, the axis along which it should rotate. Okay, when we say vector 3.up, it will rotate along y-axis, but we can make it rotate along any arbitrary axis, right? It can be at an angle as well, right? So that's how this cube is actually rotating. So if you see, this cube is not rotating along any one axis. It's not rotating along x-axis or z-axis or y-axis. It's rotating in some diagonal fashion. Okay, that is because you see the object rotation here, it is 4, 5, 1. So all three have values, which means it is not rotating along any one axis. Okay, some angle. Suppose if I make, first let me increase its speed. You can increase its speed. You can just put your mouse here, it will turn into a slider. You can drag it right or left. Okay, if you move right, its speed will increase. If you move left, its speed will decrease. All right. And here, say if I make both these zeros, both x and y, x and z zeros. It's rotating along y, but probably okay, so they are actually slightly tilted. The axes are slightly tilted. That's why it seems tilted. But the local axis is slightly tilted. That's why it's rotating like this. So when they are non-zeros, it will rotate slightly differently. Okay, so you can change it any way you want. All right, so that is what is happening. And when you are in play mode, you see there are some additional objects that came here. There is something called trackables. Earlier in AR Session Origin, we saw only AR camera. We did not see this trackables object. Okay, and there is some don't destroy on load. So this trackables is like say, now suppose Snapchat filters. Now how does it know where to place the virtual objects, right? It can be virtual mustache or ears or horns or whatever they are. So those it will know because it can detect some features. It can detect maybe our facial parts, eyes, nose, ear, lips, etc. So those are trackables. So what are the different things that you can track in your environment? Those are trackables, and those will come into picture only when you run the app, right? When you are in Unity, you don't see them. You only keep eyes, nose, ear, horns, those kind of things. So those virtual objects will be present. But where do you place them? You need to track them in the real environment. So that will come when you actually run the app. That's why you are seeing this trackables object only when you run the app. Now suppose I stop it. You see, it's gone. Okay, so that is one main thing. And then yeah, what else? Okay, so this scene, you can save it. as a scene, right? So we created this scene, so we need to save it. Earlier we were importing the scene from a package. Right now we created this scene. How did we create? We went to file, we went to file, new scene, and then AR scene template, and then this scene got loaded. Now we need to save this scene. If we close it again, this scene will be gone. Okay, so we can save this scene. So file, save as, in assets folder you have this scenes folder, right? So save that scene here. You can save it as whatever, AR template scene. Okay. All right. Yeah, so this we saw. We just saw this cube and AR session and AR session origin. So now AR session. So AR session is like, again, simple Snapchat filters example. Suppose I open the app and then I am using it. So every beginning and ending of a session, so that is AR session. So suppose I open it now, I am focusing it on my face, it is doing something. Say I save it as a video, or I need not even record it as a video. I'm just playing with it. I close it. Again, I open a different session, right? So session is nothing but an event. Every time you run the app, that is a session. Okay. And AR session origin is like XR rig, the position of the AR camera, its orientation, all those things. All right. And as you move your mobile, this also moves. So let me show that also. Let me increase the speed a bit. Okay. Now say I am selecting AR session origin. Now I am changing the position of one of these. You see, when I change the y-axis, this cube's position is changing. But why is the cube's position changing? That is because your camera is moving. Okay, so as your mobile is moving up or down, the cube is going down or up in the opposite direction. So if I increase y, what does it mean? My mobile has gone up, so the cube has relatively gone down. If I decrease y, my mobile has gone down, so the cube has relatively gone up. Similarly, x, anything, x or y. So anything you change, it is equivalent to changing the camera's position. Okay, so AR session origin represents your camera's position. All right. Okay. And you can place a different object also in the place of this cube. Suppose this cube is at 007. Okay, so what we can do, suppose I delete this. Okay, now suppose I want to add maybe some capsule in its place. So create 3D object, say capsule, and let's move its place also to 007. Okay. Now, right now this capsule just remains as it is. Okay. So when I run it, nothing happens. It's just floating in the air in that position. Okay. But I want to rotate it like the cube. So how do I do that? What do we do? How did we rotate the cube? Yeah? Rotation? Rotation script, right? Same thing. We can just use the same script for the capsule also. That's all. We already have a script. All we did was associate it with a cube object. But if you associate the same script with the capsule object, that will also rotate. You associate it with any object, that object will rotate. That's all. So here we already have the script, right? So all we need to do is go to capsule and drag this script. That's all. Okay, so now it is all these are 0, so it will not rotate. We have to specify at least one axis. Okay, so let's specify, say, x-axis. Fine. And let's increase its speed. Okay, let's test it. Still it's rotating very slowly. Okay, now let us say make this, okay, and something else, so it will rotate differently. All right, yeah, but all those changes will be lost once you come out of the play mode. So whatever changes you want to make, you have to make it here itself. All right, yeah. Okay, so before we move on with further setting up, I want to speak a little bit more about AR Foundation package. So basically it has like you can see here, AR Foundation is a set of mono behaviors and APIs for dealing with devices that support the following concepts. So all these things are available in AR Foundation. So these are all different features that are used in an AR project, right? Like first one is device tracking. Track the device's position and orientation in physical space, right? It should know what is the position of your camera and orientation of your camera, right? That's how it understands when I move it up or down, the cube goes down or up, right? All these things, how does it understand? Because it somehow tracks the position of your device with respect to your environment. And then plane detection, detect horizontal and vertical surfaces. So suppose I want to place a cube on this table, it should detect the surface of this table. Or suppose I want to place a virtual painting on that wall, it should detect the vertical surface. So horizontal surfaces, vertical surfaces, it should be able to detect so that we can perform some actions. Or suppose I want to make a person walk on the ground, it should detect the ground, right? All those things. Or if I want to place Pokemon Go, it should place it on the ground, not somewhere in the air. So plane detection it should do. In Snapshot filters, it's not just plane detection, it's different object detection, right? So all those different kinds of detections it is doing. If you remember in the initial lecture, I said AR requires both the things. One is computer vision, second is computer graphics. So computer vision is this detection of your surroundings and detecting the objects in your surroundings and analyzing. So it is analysis. It is analyzing whatever pixels it is getting, and it is detecting various things in that image or video or whatever it is. So it is detecting objects, it is detecting planes, it is detecting horizontal planes, vertical planes, right? So all these things it is detecting. Once it is detecting, then it is placing some virtual objects. So it can be a virtual cube or virtual capsule, or it can be virtual mustache or virtual 3D character like Pokemon Go or whatever it is. These are virtual things which it is placing, and it is placing them at specific positions. So for it to be able to place these objects at specific positions, it should recognize those objects in the environment, right? So first detection should happen, analysis should happen. It should analyze the image input, and then so that is done. So the first part is done using computer vision. The second part is overlaying virtual content. So this virtual content needs to be built or generated. So this is built or generated using computer graphics. So whatever cube or virtual cube or whatever entire game environment that you saw earlier, that is all done using computer graphics, right? So both these things need to come together in AR. In earlier game development, only computer graphics were there. You did not need any image detection or image processing or anything like that. You need not even worry about your environment, because that is not at all coming into the picture. Everything is virtual. Your game, your characters, your environment, your scene, everything is virtual. So you can play it on your machine or you can look at it through your VR headset. But AR is different. It needs to sort of sit in the context of your environment. So your environment is providing the context. So both these things need to interact in a meaningful way, right? Which means you need to detect your environment and various parts of your environment, which means it needs to analyze or do computer vision. And then the graphics part, whatever virtual objects you have created, you overlay them at specific positions in your environment. Okay? So computer vision as well as computer graphics, both are necessary for AR. Okay? So that's why a lot of detection things need to happen, plane detection and then object detection, tracking, all these things. So those things will come later. So plane detection, yes. Point clouds, also known as feature points. So again, so when it has to do, say, object detection, how does it recognize some object as object? Because it is sort of breaking down that object into points, and it is recognizing important features of that object, right? So and it is estimating the depth of the distance from the object. So we have seen some examples like probably I didn't show you. Have you heard of Polycam? Polycam is an app which lets you scan this entire room and give you the 3D digital twin of that room. Okay, so how is it doing? It is using not only camera but also LiDAR. Camera will only give you the pixel information, but LiDAR will also give you the depth information. How far, how far this row is, how far that row is, how far that row is. So all these will be at different distances. That is what makes this a 3D object, right? But if I just take a camera, all these will come in a flat 2D surface, like that on top of this, that on top of this, that on top of this. All these rows will come one below the other, not one behind the other, because that's a flat surface. Okay, so camera gives you just a 2D output, whereas LiDAR gives you 3D output. Okay, so how is it doing? It is throwing a lot of light rays, laser rays, and it is calculating the reflection time, and in turn it is calculating the distance of that obstruction from the camera. That's how it is calculating the depth of an object. So when I throw light on an object, how fast the light is coming back, and on another object, how fast the light is coming back. So based on this, I guess or I estimate the distance of the object and the depth of the environment. Okay, so point clouds are used for that. In fact, point clouds are also used in constructing 3D objects. So these point clouds, so basically points are nothing but my laser beams going and hitting that object at some point. Okay, so a lot of such light rays give me a sense of point cloud of that object. So that object I see as a point cloud, cloud of points. Okay, later using these point clouds, I sort of try to reconstruct that object using various techniques. I triangulate them. You would have seen mesh representation, right? Lot of triangles, 3D objects represented using lot of triangles, right? So that mesh representation I will do, and then I will give colors to that. So there are various layers in which you represent 3D objects. Okay, so point clouds are used not only in graphics but also in detection. In this case, in AR's case, as the first step, it is using them for detection. Later you can use that data to sort of create the digital twins also. If I want to convert this object into a 3D object, if I want to create its digital twin, I need to get its point cloud. And then using this point cloud, I get an estimation of its shape. And then I will fill that shape with triangles and then colors. So that's what we do, okay? And anchor, an arbitrary position and orientation that the device tracks. So if you had noticed in this video, it is seeing the cube, then it panned left, and when it came back, the cube is still there, right? The cube is not moving with the AR camera. The cube stays wherever it was. You see, that's another difference between AR camera and other camera, right? Normally in the project, the cube is in front of the AR camera, right? But when we are moving our camera away from the object is not coming with the camera. It was staying wherever it was in the original environment. How? It is because we have anchored that object to that coordinate. So there is a virtual coordinate there to which the object is anchored. Okay, so these anchors are visible only to the AR camera, not to us. So these anchors are placed at different places so that even when you move away from that object and come back, that object remains there itself. It is anchored to that location. Okay, so anchors are used in AR. And then light estimation estimates for average color temperature and brightness in physical space. Environment probe, a means for generating a cube map to represent a particular area of the physical environment. Everything you need not understand now. Some things which you can easily understand, I am explaining now. Some other things you will understand as we do some projects. Face tracking, detect and track human faces. That's how even when you move your face away, the virtual objects also move along with your face. It's not like they remain there and then your face moves, right? It's tracking. So not only detection, but also tracking is important. Tracking means motion of the object. So static objects, if you just detect, it's sufficient. But what about moving objects? It's not sufficient to just detect them. As they are moving, you should constantly keep detecting them. You should constantly keep tracking them. Okay, so detection is also important, and then tracking is also important. Okay, so face tracking and then 2D image tracking, detect and track 2D images. So 2D images in the sense, suppose there is a QR code. Okay, now I want to place forget QR code. Suppose there is a floor plan of a building. That is a 2D. Now I place the 3D model of that building on that floor plan. I attach that 3D model on that floor plan. Now, as I move that floor plan, if I move that floor plan away, the 3D model should also go with that. It should keep sticking to that floor plan. Okay. So in this case, what are we doing? We are doing image tracking. So it is not plane detection. It is not face detection. It is an image. So we can overlay 3D content over 2D content, 2D images, or say it's a textbook page. Some lab experiment is being discussed. Some image is given there. Maybe, or not even lab experiment. Say solar system. Some solar system image is given there. I want to overlay 3D solar system. How the planets are moving. What are the relative sizes. How the orbits look. All these things I want to overlay. So first I need to build that 3D system somewhere, and then whenever I detect this image of solar system in the textbook, I overlay this 3D object on that. Okay. Now say if I move away, if my camera moves slightly this side, that side, or if this book moves this side, that side, this solar system should go along with that. So it is tracking that image. Okay. It's not like if I remove that book, the solar system remains here. No, it should go with that book. Okay. So image detection is another thing. Image tracking is another thing. And then 3D object tracking. This is again a very useful thing. Suppose if your car broke down and you want to repair your car, so you open the bonnet and you look at your engine. Now there are many parts in your engine. You don't know which part means what, which part needs to be repaired, right? So all these things. So suppose if there was a mechanism through which different parts of your engine are labeled. So suppose you open your mobile app and you point it at the engine, and then it labels, okay, this is carburetor, this is engine, or this is wiper, this is where you pour water. So different parts are labeled, right? How does it do that? It is detecting different 3D objects there. Or suppose when I point it at a car, it just says this is a car. So it is detecting a 3D object. So it's not an image, it's not a plane, it's not a face. It's an entirely different 3D object. So if you can recognize different 3D objects, again there can be whole lot of applications. It can be used in medical applications, it can be used in surgeries, or suppose it can be used in industry. Suppose you don't know how to operate a big machine, you can point it at that and it can detect different 3D parts, 3D objects, and then label them. Or it can also give instructions, okay, move this first, move that first, right? All these things. So 3D object detection and tracking, that is also important. And then meshing, this is what I said, mesh. You have point cloud and then you create a triangular mesh of it to give you the shape of the 3D object. And later you fill it with colors. You know triangle mesh representation of an object, right? I need not show you. These are all mesh representations, right? So this is how you are sort of, the more triangles you have, the more finer it is, right? And then you fill these with colors. You fill each triangle with a color. That's what we do. Okay? So initially we just have point clouds. See, this is like, no, this is, yeah, this is mesh. Yeah. So this is point cloud. So you have a lot of points and then you convert it to mesh and then you give it texture and colors so that it looks very realistic, like a 3D object. Okay? So this is how it is done. Yeah, generate triangle meshes that correspond to the physical space, and then and so this is about generating completely virtual objects. But suppose I am capturing some physical environment, this also, basically what is it doing? It is converting this to a 3D object. So for that, first it detects points, so it generates point clouds, and then it generates the mesh representation, and then it converts it to a 3D object. Okay? And then body tracking, 2D and 3D representations of humans recognized in physical space, and collaborative participants track the position and orientation of other devices. So suppose you are playing an AR game. So suppose if I am shooting some object, someone's suppose if two people are lifting an object together, so it should understand both the devices orientation and all those things. So it's a shared, it's a collaborative participation. And then human segmentation determines a stencil texture and depth map of humans detected in the camera image. Depth maps, so this is an example of depth map. Can you guess which portion of this rabbit is front and which portion is behind? A squirrel, sorry, yeah. Yeah? Face is front and the remaining body is behind, right? How are you able to say that? Sorry? Suppose if I give a flat image, you will not be able to say this. You will think, okay, everything is in one plane. But here it looks as if something is in front, something is behind. It's not because of the structure, it's because of something else. What is that? The color gradation, right? So lighter pixels are at the front and darker pixels seem to be behind. Okay? So it is in human eye, the ability to detect this difference. Okay? So given an image, we can extract the depth map from it. Some pixels are of a darker shade, some pixels are of a lighter shade. In this case, it's only black and white, but even in colored pixels, we have this gradation. Okay? So using this gradation, we can extract the depth from the image. So that is called depth map. Okay? So this is not a normal image, this is a depth map. Okay? All these are depth maps. You see, all of them seem to be like 3D things, but they are actually flat 2D images. They are not 3D objects per se, but still they give you a sense of 3D. right? This one, you see, this seems to be at the foremost, and then slightly behind, and then more behind, right? It's all because of the color gradation. Okay? And yeah, human segmentation. So depth map of humans detected in the camera image. Raycast queries physical surroundings for detected planes and feature points. So raycast means it shoots the rays to get, okay, where is the plane, where are some other points, where are 3D objects. It keeps shooting the rays. So there may be some errors during this process, like suppose if an obstruction comes in between, then what happens, right? Or if the room is not lit enough, if it is dark, then how does it detect? So these are actually research questions, okay? And then pass-through video, optimized rendering of mobile camera image onto touchscreen as the background for AR content. So what does it mean? So when I am looking at the room through my camera, and suppose I am overlaying a cube, now actually mine is a black background in the in Unity, but I am sort of cutting that all out except the cube and then letting the light pass through onto the screen. So I'm not letting the light pass through only where the cube is there. You understand? Technically cube is not there at all. It's only in the software. When I am looking at this room through my camera, what is happening? The light is falling there and getting reflected and falling on my camera. Out of these light rays which are reflecting, I am allowing all the light rays to pass through except the light rays which are overlapping with the cube. So that's a very complex computation, right? So which portion of the light rays to cut out? I need to calculate that. So that's what this does. So pass through video. Optimized rendering of mobile camera image onto touchscreen as the background for AR content. You are rendering, everything is rendering, not only graphics is rendering. Any image processing is rendering, any image is being rendered onto your screen. Okay? And session management, manipulation of the platform level configuration automatically when AR features are enabled or disabled. Occlusion allows for occlusion of virtual content by detected environmental depth. Environment occlusion or by detected human depth. So in this case, although the cube is in the midair, we assume or we understand, okay, if I put a hand at some distance, this hand should obstruct the cube, or if I put a hand after some distance, that cube should obstruct the hand. So occlusion means obstruction. So how to handle this obstruction? When does the object coming in front of camera occlude the virtual object and does not occlude the virtual object? Okay, so all this decision making is also part of this. Okay, so these are all so many things. So AR is a very complex thing. It's not as simple as game development or VR. In AR, so many things need to be done. So many, basically because of this interaction between physical and virtual, so much processing needs to happen. Okay, so these are all the different stages, different features in AR project. Okay, so as we do more projects, you will get a better grasp on these concepts, but we will not get into handling these concepts directly. They will be used at the back end. Okay, that's in advanced. You can think if there's an advanced course, these will be taught in that, but right now these will be used, these will be done automatically by the system itself. Okay, so let's stop here.